So we at ARM TechCon 2010, and you are from NXP.
Correct.
And you're showing Cortex-M series solutions, right?
Mm-hmm.
So could you say a little bit the Cortex-M? What is it for?
Oh, NXP offers a wide variety of Cortex-M cores from M0 to M4, and they have a wide variety of different application spaces. The M0 is intended for 8 and 16-bit replacements. It's an easy-to-use core, small instruction set. The M3 is more of a little more powerful, has a broader instruction set, hardware divide, things like that, a lot more peripherals. And M4 is for DSC applications. It has a single cycle multiply accumulate instructions. It has SIMD instructions, really meant for more DSP applications. And I think the most exciting thing, though, about our M4 family is we include an M0 core in there to take care of housekeeping, as an example, peripheral management, communication, where the M4 can concentrate on what it does best, and that is DSP solutions.
But the Cortex M4, for example, is kind of like a new announcement. It's not very old.
No, the M4 was announced earlier this year by ARM, and we've taken that on and included it in our LPC 4000 family.
And the other Cortex-Ms are older, or?
The M3 is the oldest core in the M series family. The M0 is newer, and the M4 is the newest one. So that's kind of how it progressed.
And it's the whole Cortex-M series is one of the core competencies of NXP. Is very good at that, right?
Yeah, correct. I think we have one of the best offerings of the widest core offerings, and within the offerings we offer the higher performance, both frequency and performance. I think that's something that a lot of people have to understand, that performance doesn't necessarily mean frequency, it's how much you can do within a given clock cycle, right? And for us, we have one of the highest benchmark scores out there for our Cortex family of parts, and they're very power efficient as well.
So let's do a tour so we can check out,
Sure.
try and understand some of the use cases.
Okay.
So this is a Cortex-M0.
Yeah, this is a Cortex-M0. This is one of the smallest 32-bit microcontrollers available today in a CSP package, and it has a 2x2 footprint. Now, this is not just a simple microcontroller. It's got 32K of flash, 8K of RAM, SPI, UART, timers, full complement of peripherals.
So it's just this little right there.
Yeah, that's correct. That's it right there.
So why do you need all that stuff around?
You don't.
You don't?
No, you don't. The idea is that it needs to be on a board, and this is our Espresso platform, and it's just showing how that can be used in our open tools, right?
But products out there in the market that use the M0 could be as small as what? As a chip? No,
it could be as small as as small as the chip. I mean, all you need is some board support, something to support the part on a board. A few little capacitors, and that's it. I mean, you need bypass capacitors, but there's the IRC internal oscillator already on there that's trimmed with 1%. This part runs at 50 megahertz, right? So I mean, just up to the imagination of the designer, what they can do and where they can put it.
They need to get power somewhere, and
power is important, right? As in all embedded systems, you need power. But as far as power consumption is concerned, this guy, looking at microamps per megahertz, which is a metric that a lot of companies are using these days, this part consumes about 130 microamps per megahertz, has a power down with state retained of less than 2 microamps, and in a deep power down mode without state retained, it's about 220 nanoamps, right? So I mean, there's just a lot of different power down modes, but very, very low power consumption performance for a 32-bit controller.
When you talk about nanoamps, it means that it can stay in deep standby for like months or years?
For months, it depends on the source, right? So as an example, if you have a microamp with like a coin cell battery that's 220 milliamp hours, that's 10 years, right? 10 years.
All right. And so what are you showing over here with that?
Okay, so this is just showing the small part and the size of it compared to, we're just looking at the part in this package. And then we have other things we're showing. We have the LPC Espresso platform that is really a free tool from NXP. And we're showing a wireless demo where we have the LPC 1102 that's being powered by a energy source that's taking its power by inductive reactor, right? So as the metal moves through this coil, it powers the device. There's no batteries or anything like that in here.
So
right?
you could power it, but it's not a...
Through vibration, right?
Yeah.
Through vibration, right?
Okay.
And so we have a demo that transmits RF and RF signals to a base station, and this was we're moving something on screen.
Nice. And what's over there?
Okay, so this is the newest Cortex M4, and we have a motor control demo running. So it's communicating with USB using the M0 and doing FOC motor control with the M4. So that's what it's showing the power of the two different cores.
All right. So right there is just like a demo showing some...
Yeah, so this is the motor control part, right? This is a motor using FOC. FOC is field-oriented control, right? You don't, so it's a centralist control, and it takes a lot more horsepower to do that kind of application. And then as far as communication is concerned, that's being taken care of by the M0. And then we have a demo of, since there's two cores inside, we have a demo of, why is it, this is not on.
Do we need the power?
I think we need the power.
Maybe.
Yeah, this is John's computer. This is an application of a Cortex M3, a 1313, very low cost M3 microcontroller. People say, why are you driving a Volkswagen with a Ferrari engine, right? And that's not the point. I think the idea is these coffee machines are really sophisticated. They have to take care of temperature, right? They have to take care of what the pod is. These pods have a particular temperature they want to be brewed at, pressure to make a good cup of coffee. So it's not just simple things that controller has to do. In fact, that 1300 is just barely at its limit to do all the things that coffee machine needs to be done to make a good cup of coffee. So I think that's really interesting. So,
is it on the market?
Yeah, it's on the market. You can buy these now. This is a Bosch Tassimo coffee machine, powered by LPC 1330. So I guess the question was, what was the cost of these machines? You know, and I'm not really sure. I think they're under $100. Check at your local Amazon or other retailer, but you know, for a great cup of coffee, price is never an issue.
And then you can choose the temperature of your coffee and...
Oh no, as far as the temperature is concerned, coffee has to be brewed at the correct temperature or it tastes like crap, right? Same with tea, right? So black tea, always 190 degrees, 180 degrees. Green tea, 170. So it's really important that you brew at the right temperature, else it doesn't taste very good, right? So that's what this thing takes care of.
And in this area right here, it smells like the coffee is really good.
Oh, awesome. Excellent coffee.
Okay, thanks a lot.